what you have to do is to square the given is like square root of a plus square root of a squared plus b squared. Where they say a, they say 4. Where they say b, they say 3. But we have to square them inside, and we place them inside the brackets. Therefore, we press our calculator and we get the value of 5. So from this one, we did the same thing. We solve it the same way that we did to our example number 1. So if you can check here, even this one, we did the same thing. We take even the sign of our A and B, which is our real and imaginary. Remember, when we are talking about A and B, we are talking about a real and imaginary way. A is the real on the x-axis, which is our horizontal line, and the B is an imaginary on our y-axis, which is a vertical line. So as far as we concern, now let's talk about a rectangular versus a polar. So on rectangular is when we are dealing with A and B, but when we speak about polar is when we're dealing with R and Q. So before I proceed, a complex number, you have to take note. You can define, they can ask you this definition on your exam or test or whatever you call it. So now, a complex number is the number which is defined by z, which is equals to a plus ib, where we have already spoken about it. Where a is a real number, I'm repeating what I have said, and b is an imaginary number. So before we proceed, any question? Question, anyone? Any question before we proceed? Guys, you have to ask any question before we proceed. Yes, silent means that we are at the same page. So now, let's proceed. So as far as we concern, let's talk about a complex number also. So a complex number, we'll be talking about z, which is equals to, guys, is there anyone who is recording the meeting? Huh? Hello?
Yes, the meeting is being recorded.
Recorded, eh? I to recorded. Abaridze murudzi votsima maiki we. Mashudu chisapungo question.
I don't have a question for now.
You raise your hand.
Oh, it's a mistake.
Okay. So now, let's proceed. So as far as we concern, let me check. Okay, right. So now I have started to record the meeting now. I thought you guys are going to record the meeting, but it doesn't matter. So now, so guys, you don't have any questions here. we've talked about complex, which is z equals to a plus b, I, where a is a real and b is an imaginary. So we show by the diagram how we can plot those things on our Cartesian plane. So now, when we are talking about z is given by this, which is like we want to find it's like we're using the theorem of Pythagoras, which is this one, which is the root of a squared plus b squared. We use the diagram. So example, z equals to 4 plus 3i. So find the absolute value of z. We apply the square root and we square a and b. So, but here our a and b. Hello? Hello?
Hey.
Yeah, network it on covered by the. Can you see my screen?
Aye.
You can't.
Not yet.
You can't see my screen.
Aye.
Are you serious?
Yeah, I'm going to one.
Now,
So now, I was talking about a complex number. A complex number is denoted by z is equals to a plus ib, where I is equals to root of -1. I say to you guys, press your calculator and find what is root -1. Guys, can you hear me? It's undefined, eh? But in this mathematics, it's not undefined. It's equals to -1. I, you put I. Are we still together? So it's like when we're saying root of -4, it must be 2i. Are we still together? Hello?
Yes.
Yes, it must be 2i. So now, if we're representing those, when we're dealing with a rectangular, A is equals to REZ and B is equals to IMZ, where REZ is a what? A real number of what? Of Z. Are we still together? IMZ is the what? Is a? Hello? Remember B is a what?
Imagination.
It's an imaginary. I am is an imaginary of Z. Are we still together? This means that is an imaginary of Z. And this means that is a real number of Z. Are we still together? It's a shortcut, RE for real number, IM for imaginary.
Sipho.
Nda.
Ezwi zwori is an imaginary number zwa zwi amba uri mini zwavhuḓi vhuḓi nayi.
Imaginary number ri vha ri khou amba kha dzine dza dependa kha real number. Real number ndi dzi dza x axis, imaginary ndi dzi dza y axis.
Okay, so sharp imaginary number ndi dzi y axis zwavhuḓi vhuḓi ndi dzi y values.
Yeah, hafha kha itshi tshivhumbeo ndi dzi y values.
All right.
Rangari every number everything is always to the power of exponent 1, but we don't write 1. 1 is an imaginary. Ri vha ri khou tou zwi
Ando xela.
ambisana.
No ndata.
Okay, imaginary number ne? Imaginary number is a complex number that can be written as a real number multiplied by the imaginary unit I.
Okay.
Zwamba ri khou amba nga imaginary ndi tshone tshithu tsho no multiplyiwa nga I.
Oh, zwi amba ahuna case na nthihi ine ra nga wana A i khou multiplyiwa nga I ne?
No.
Okay, thank you.
So which is defined by what? Its property I squared. In a I squared, the I squared is equals to what?
-1.
-1. You see? So an imaginary number is a complex number that can be written as a real number multiplied by its imaginary unit I, which is defined by the property I squared, which is -1. The square root of an imaginary number is BI. Okay. Minus B squared. Rotary. Receiving.
Yeah, receiving.
So now, let's talk about we will talk about addition or multiplying or dividing a complex in a rectangular form. Guys, any question here before I skip? Guys, take note here. Take note. A is equals to REZ for real number for Z. And B is an IM. IM is like is a abbreviation of an imaginary number for Z, for vector Z. Are we still together? So now, I'm using my data here. If it cuts you, it means we are out of data. So you have to accept that. until we reach 11 o'clock. So now we have got let's talk about addition of complex number. How do we add the complex number? So here we are. Let's say we have got a Z1, which is equals to A plus IB, and we've got Z2, which is equals to C plus ID. Then Z1 plus Z2 is equals to what? Is equals to A plus C plus I open bracket what? B plus D. In other words, real by real, imaginary by imaginary. Are we still together? Hello? Are we still together? So now, guys, you have to talk. I can't talk alone here until the end of the class. So now, let's say we've got Z1, which is equals to 1 plus 2i, and Z2, which is equals to 2 minus 3i. So let's add Z1 plus Z2 equals to 1 plus 1, which is give us what? 3. And 2 minus 3, which give us minus 1, but it was for what? For an imaginary, which have got what? I. Any question before we proceed?
Bro, what is your name?
When we're adding those imaginary, when we're adding those two equations, addition, we say imaginary by imaginary. We say real by real, which is what?
3.
3. It's like we have this. You see? When they say A, they say 1. When they say C, they say 2. Say plus I open bracket. When they say B, they say 2. When they say D, they say minus 3. Therefore, you arrive to this one.
Okay.
Did you see that?
Yeah, so far.
Okay. So now, let's go to multiplication. Guys, I'm repeating myself, right? I said I squared is equals to what? I squared is equals to what?
-1.
Is equals to -1. Are we still together?
Yeah.
So now, if I squared is equals to -1, you have to know wherever you meet I squared, you must substitute with the -1. Are we together? Okay. So now, here we have already spoke about it, where we are adding. Am I too fast?
First nyana.
Don't you see again?
Yani ngunsi go tamburi nguchimbela first nyana.
No, chimera data. So now, let's see, multiplication. Z1 times Z2 is equals to what? Open bracket, 1 plus 2i. We're using the same values, those ones, right? Where this is Z1, we substitute with 1 plus 2i. Here it is. Where they say Z2, we substitute with 2 minus 3i. Here it is. So now, what do we do from here? We remove the bracket. You know how to remove the bracket. Bodmas first by first, first by second. Now it's done. 1 times 2, 2. 1 times minus 3, minus 3i. Therefore, we are done with 1. Now 2 follows. 2i times 2 is 4i. 2i times minus 3i is minus 6i squared. Are we still together? So now we group the like terms. Those are the like terms. We press our calculator. Minus 3 plus 4 is 1. For what? For I. But we know that this guy here, this guy is equals to what?
-1.
So where they say this guy, we're going to substitute with -1. Are we still together?
Yeah.
Yeah, therefore, you simplify 2 plus I minus 6 into minus 1. Therefore, 2 plus I minus 6 times minus 1 is positive 6. You group the like terms. Like terms is this one and that one. Therefore, you get what? You get this guy here. Any question in addition and multiplication of a complex number?
Una question
Hauna question eti? So let's talk about the conjugate of a complex number. So when we're talking about the conjugate of a complex number, let's say if z is equals to a plus ib, we know the equation of z now, anyone can sing that. What do we mean by a complex number? Or we know that the complex number is given by what? The equation of what? Z equals to a plus ib, where a is a real number and b is an imaginary number. Are we still together? So then, its conjugate is the number denoted by. The conjugate of a complex number is this one. If you can check the difference between this question and that one, you can see that, oh, where there is an imaginary, we have changed the sign. Are we still together? We only change the sign of the imaginary. You have to take note. We always change the sign of an imaginary to get what? The conjugate. Are we still together?
Yeah.
Not Colgate, conjugate. So now, I have given you guys the example here. Let's say you see, we are given z is equals to 2 minus 3i. Find the conjugate of it. The conjugate will be what? Where z is equals to 2 plus 3i. Are we still together?
Yeah.
So if you can check even this one, z is equals to minus 5i plus 2. The conjugate, we only change the imaginary number. Where there's an imaginary number, we change the sign. Are we still together? Now is give us what? 5i plus 2. This one for real, you leave it the way it is. Any question before I proceed? Any question? So now, let's talk about multiplying. Let's say they give you an equation, they say write in the form of z equals to a plus I. They only give you those two things. They gave you two, let's use this one and that one. So let's use this one. We are given those two equations. They say write in the form of what? Z equals to a plus IB. What you have to do is to divide. You have to divide. Are we still together? So when we are dividing, unamto vura maiki if usiropocha them. Unamuto vura maiki TV yoshaba stichini. So now let's proceed. You are going to, if you are given those two equations, they say find, write them in the form of z equals to a plus ib. So now this is what you have to do. You have to say equation 1 divided by equation 2 is equals to 2 minus 3i divided by 2 plus 5i. So we always multiply by the conjugate of the denominator. So the denominator is this one. Remember, on the conjugate, what do? We change the sign of what? We change the sign of what? Often we change the sign of what? This is what?
Imaginary.
We change the sign of the imaginary. So now we multiply by the conjugate of the denominator. So the conjugate of this one is 2 minus 5i. So we can't just say multiply by the conjugate. We multiply by 1, or we represent 1. Why? Because if we only multiply by this one only, we will change the equation altogether. We multiply by 1, it's like 1, this one, and then this one and this one can cancel each other quickly. So after multiplying, here we don't cross multiply. Denominator by denominator. Those things for rationalizing is the same or similar as the one that you did in Math 1141. So now we are going to multiply. It's like here we are multiply 2 brackets. Are we together? 2 multiplied by 2, it gives us 4. 2 multiplied by minus 5i, it gives us negative 10i. Therefore, we are done with 2. Now we are going to 3. Minus 3i multiplied by 2, it gives us negative 6i. Minus 3i times minus 5i, it gives us positive 15i squared. But guys, whenever you meet this guy, right? This guy is equals to what?
Negative 1.
Yeah, so don't be surprised when we remove this guy when we are going with our steps. So now, do you still remember when we were doing Maths 41? We meet this kind of those two guys when we were doing our Maths 41. Do you still remember? This is when we are multiplying those two. What do we apply? This is the square, this difference between the square. So we don't say this one times this one and this one. No, first by first, second by second. This is what we get. Any question from the difference between the square? Okay, so now when we proceed, we're going to group the like terms. We're going to press our calculator and we say negative 10i minus 6. Negative 10 minus 6, it gives us negative 16, but it was with I. Plus this one, we copy it the way it is. We copy the numerator, the denominator the way it is now. So now, on this guy, we have substituted with the negative 1, right? And then this guy is equals to negative 1. So where this guy, we substitute with the negative 1, we press our calculator. 4 plus 15 into negative 1, it gives us minus 11. Therefore, minus 16i divided by. Even on this one, we substitute, we know that this guy, it is equals to negative 1. So we're going to say 4 minus 25, open into negative 1. It gives us what? 29. So remember, from the law that we use to simplify things, to arrive to this step, we must first find the LCM. So when they find LCM, they arrive here. So we have to take this step back. So it's like when they say negative, each and every number that is on the numerator is divided by this one on the denominator. We are separating them now. It's negative 11 over 29 minus 16 over 29. So this is what we call is in the form of what? Of this one. Can you see that? Can you now see that?
Yeah.
we have reached what they asked. So you have to take note. We divide equation 1 by equation 2, therefore we multiply by the conjugate of the denominator always. Can we proceed?
Yeah.
So now, any questions, guys? Any question? Question anyone?
No.
No question, right? Okay. So now, they show that this question was question number 7. I don't know which question paper, but I think even on the one that I'm going to send you on WhatsApp, it will be like that. So now, those are the questions that when they come on the exam, if you have attended the classes very well, you must jump and stand on the table and say yes. So now they show that Z, W, an element of C. Guys, what is this?
Imaginary of Z.
Imaginary of Z.
Which is equals to what? Which is equals to what?
Which is equals to mini imaginary of conjugate.
Moses. I think I have written those things down, right? Didn't I? Define complex.
Don't know. Conjugate.
Define complex. It's on the screen. Can someone study for us complex, the definition? Promise, where are you? Guys, time is money.
Complex number is a number which is defined by Z, which is equal to A plus imaginary of B, where A is a real number and B is an imaginary number.
And B is a?
Imaginary number.
Meaning that imaginary is equals to what? Huh?
Imaginary equals to B.
Yeah, that's what I want. So now, we know from this proof, they want us to prove this. Those people, they want us to. Guys, you have to participate. Girls, where are you? Millie?
Nende compatibility.
Neshauru? Ewe Neshauru? Kane participate Neshauru adera. So go see a phone online. Neshauru participate. Not her na Sweden. So let's proceed, ne? So from this proof that they want us to prove, we know that imaginary of Z is equals to what? B. Are we still together? Okay?
Yeah.
And we know that Z is equals to A plus IB. That's what we know from a complex number and from a complex definition. And if we know that our z is equals to a plus b, we know the conjugate. Remember, this represents the what? The conjugate of what? Of z. So what we have to do now is to tell those people that let our z is equals to what? I plus b. So now it means from our left-hand side, but we know that from our left-hand side, we have got what? Imaginary of z, which is equals to what? B. Are we still together? Meaning that we have to work through our right-hand side so that we may arrive at the left-hand side. Are we still together? So now, our right-hand side is equals to 1 over 2i into z minus the conjugate of z. Now we substitute. So we have got y over 2i into a plus ib minus, when they say conjugate of z, we apply. We change this one a sign. But remember, we only change the what? The imaginary. Are we together? So now it's negative into a minus ib close. So now we remove the brackets. The inside brackets we remove. It means we are going to have what? We are going to have negative times a is negative a. Negative times negative ib is positive ib. Then we group the like terms from this step. From this step, we group the like terms. So if you check, we'll find that a and negative a, they're going to cancel each other, and the ib and ib, they are the like terms. So this is 2ib. And when you check here, we have got outside, we have got 1 over 2i into 2ib. 2 and 2 cancel, and I cancel. Therefore, we left with what?
B.
With b. And b is our what? Is our left hand?
Imaginary.
Yes, is our imaginary, which is what? Which is on the what? Which is on the left hand what? Side.
Left-hand side.
As you can
Okay.
see. Are we together?
Yes.
So it means we have proven, right? And then those people, they want us to prove that I imaginary of this one, which is b, is equals to 1 over 2 into z minus conjugate. Here it is. Any question?
No question.
No question, eh?
Yes.
You said you don't have a question, right? So now, let's proceed. You conclude, right, what they ask you. Therefore, z, w, e, an element of c. Imaginary number of z is equals to 1 over 2 into z minus conjugate of z. Are we together?
Yes.
Yes.
We can take some funds here. Let's say I to the exponent of 7. You can write it as what? So what do we need here, right? What we need here from this one? We know us ourselves, we only know that I to the power 2 is equals to -1. So we have to represent this as I to the power 2. So meaning that this one is going to be equals to what? I to the power 2 close to the power 3 times I. We must have I at the end, and we must have I inside. So this exponent, you know how to find it yourself. You know, how are you going to get it? Because if you know that there's a 1, it means if we subtract 1, we're left with the 6. So how can we write 6? 6 divided by 2 is what? Did you see how do I do that?
No.
We
Yes.
subtract 1 here from 7. This is our 1 here. This I represent that 1 on the 7. So we are left with the 6. So from 6, we have got 2 and what? That we can multiply. We say 6 divided by 2 is 3. It means inside we must have 2 because we know that we only know I to the power 2. We don't know I to the power 3. Outside we are going to have 3. Are we together?
Yes.
So where they say I to the power 2, we know that that guy, it is equals to what? -1 times what? Times I. Therefore, this is -1 times I, which is -I. Did you see that? Same applies to this one for I to the power 99. We know we subtract 1, which is which one? Which is this one. And we're left with what? 98. 98 divided by 2 is what? Is 49. It means 98 will be inside. It means I2 it will be inside and 49 it will be outside. Therefore, you press your calculator. -1 to the power 49 remains the same. Any question? Any question, guys?
No.
Sipho, can you please repeat? Ndandola tongana nga network. Kama repeateliwa ndandola tongana network enyana kwa.
Or repeat it, Rabio. Or repeat it.
Utama kwa custom.
Oh, some
Utama
fun.
kwa custom.
Some fun. So some fun, we know that we are guided by this guy here, which is I squared is equals to -1. So we have to represent those things using this guy. So now we must always have this guy here outside, which is 1. It means we can subtract 1 to our given equation like this. So now 7 exponent, we're dealing with the exponent, and then this is always to the power 1. So 7 minus 1 is 6. It's like we have got I to the power 6 times I. Are we still together? So how can we write I to the power 6 using this guy? It's like we're saying 6 divided by 2, which will give us 3. But our 2, it will be inside. Our 3, it will be outside. Remember, law of exponent is 3 times 2, which will give us 6. But we know that this guy is equals to -1. So where there's this guy, we're going to substitute with the -1 and so on and so on. Press your calculator. We do the same thing to the next one. Where there's this guy, we always remove 1, which is this one, and it's like we're left with I to the power 98 multiplied by I.
Sipho. Arali ri dilana na exponent ya I even number. Apa ri tshi ṅwala ri ya ṅwala yono ri ya ṅwala decimal. Apa ri tshi khou divide nga 2.
Ani.
Let's say ro fhiwa I to the exponent of 20 ne. Athi ri khou tea u thoma ngo subtract 1.
20 divided by I, divide ya ri subtract.
Divide ya ri subtract.
Hafha ndi ya musi ri tshi khou dilana na dzi order.
Okay, huna tsumbo hafha noni ya musi u khou dilana na dzi even.
Hai, ndi ngori ni ḓivha ya dzi even k ndi hei fhedzi 26. It's like you know that no for yon.
A thi khou frustana.
Ṅwalani hezwi fhasi.
Okay.
I
Yeah.
to the power of 10
Sure.
is equals to open bracket
Yeah.
I to the power of 2 close to the power of 5.
Okay.
Which is equals to open bracket minus 1 close to the power of 5. Now let's calculate.
I is there. Archati on I ne.
In the one number. Okay, even in the one number.
Okay.
Yeah.
Sure.
So can we proceed?
Yep.
Hello?
Yeah.
So now,
Yeah.
let's talk about what we call a polar form. A polar form. A polar form is when is given by the equation of Z is equals to RCIS theta. If you can check the diagram at your right hand side, it's like that. So now, in this diagram, you guys, you know how to use what we call soccer tower. So when you are using a soccer tower, you know that soccer tower, which is SOH space CAH space TOA. Soccer tower, written with the capital letters. Where so means sine theta is equals to opposite over hypotenuse. Where ka means cos theta is equals to adjacent over hypotenuse. Where tower means tan theta is equals to opposite over adjacent. So now, if you can see here, our x-axis is represented by A. As you can see that we have spoken that a real number is on the x-axis. And our y-axis here, which is the opposite, is represented by B. Are we together? So from this triangle, find sine theta in terms of ABR. You find that what? Sine theta is equals to what? Hello? You find that sine theta is equals to what? Rabia to vidzererana na. Nechauru. Omutu one.
B over R.
Nechauru one.
Master kumbomiselwa kha diagram.
Okay, guys, are we still together? Can you see my screen?
Yeah.
Yeah.
Okay. So now, let's talk about polar. A polar form is Z is equals to R CI as theta, where I said you guys, you must find sine theta and cos theta. Be fast.
Sin theta the B over R, cos theta the A over R.
As a network, it's on there. Network weta zvayo ungoiona. So khazo zwithu zwena wana uri sin theta ndi mini?
Sin theta the B over R. B over R.
Okay, no sin theta ikulingana B over R, cos theta ikulingana A over R, ndi zwone ti? So khazo zwithu solve for A. Zwamona kuti yo cross multiply. Kha ichi chimwe ni solve for B, you will arrive here. You will find that your A is equals to R cos theta and your B is equals to R sin theta. But we know the value of R since we have studied. R is given by, it's a theorem for Pythagoras, root of A squared plus B squared.
Yeah.
Are we still together? So when we're talking about rectangulars, we know that Z is equals to A plus IB, where Z is equals to, where they say A, we substitute. Our A is equals to R cos theta. Here it is. Where they say B, we substitute. Our B is equals to what? R sin theta. But it has got I here. Is I R sin theta. Any question? But you have to know that tan theta is equals to what? Opposite of adjacent, which is A, which is B over A, right?
Yeah.
Therefore, theta, sorry, I write alpha here. This is a theta. It must be theta. As since we're dealing with a theta, né? It must be theta here. Theta is equals to tan arc A over B. We know that you have to take note that our angles must always be in radius. You must turn on your calculator to radius. Unamutara kuridza music kana ndi radio dzobuya ujobeke. Nechidziva vanhu.
Enda.
Asinwi.
The mistake. The commute.
So now, Z depend on the location of theta. It depend on the location of Z. Kana ndo vakhedza ngapa mrao. when I say theta is equals to tan arc B over A. Abango khera di. Sorry cherote. Chipatana nichaone inui.
Yeah, sure.
Cheropana.
Yeah, Charlotte.
Sipho.
Okay, Millie. Hey, boss lady.
Hey.
Yeah, mulutanyi nomfako seya. Una mtu yavakombidzerera apa kambe ndotecheresa.
Ndikumbuliselwa nthaka ino ni ya alpha watatu. Tan watatu. Wait.
Mwarani izvi tan theta is equals to rikuchimsei triangle yacho iyi. Tan iri opposite ine yava B over adjacent ine yava A. Rote. Zvino rokusolva for angle theta. Rija tan yanga inke. Zvamburi imbodhisvika yari arc tan.
All right.
So now, so as far as we concerned, can we proceed? I have said that theta depend on the location of Z. So this is the location. This is our Cartesian plane. Okay, before we talk about Cartesian plane, let's come here. Our theta rad is equals to 180. So 2 theta rad of yours is 2 times 180, which is will give us 360.
2 theta rad.
2 rad, 2 alpha man. Yo, not alpha, pi. Our pi rad. Our pi rad is equals to 180. At least nobody want to know pi ni atatanu amba.
Okay.
Our pi rad. Ribanji. So our pi rad is equals to 180. Therefore, our 2 pi rad is equals to 360. So now, when we are using the Cartesian plane, we know that theta is equals to alpha. So meaning that theta is equals to 180. So now, on the second quadrant, we have got what? Is one remember on the trigonometry. This is change 180 minus theta. 180 plus theta. 360 minus theta. Rengasi shumise 90 na 270 nguri chincha. Rote. So now, as far as we concern, here is the example. So on the example, we have got Z, which is equals to 1 plus I root 3. Where R, we know our R is equals to root of I 1 squared plus open bracket root of 3 close to the power 2. We press our calculator, we get 2. So theta is equals to, hello? Theta is equals to what? Tan of A over B. Can you see that? Guys, I was
Yeah.
Theta is equals to what? Tan of A over arctan A over B. All together.
Arctan.
Where
Yes.
A and B are here on the Z. So now, don't be surprised when I wrote tan theta. Theta equals to tan arc root 3 over 1. I got it here. Our A is what? Is 1. Our B is what? Is root 3. Are we together?
Yes.
So here we find what? We find 1 over 3 pi. So meaning that our Z, we know that our Z is equals to what? Hello? Our Z is equals to what? R CIS theta, right? Can you see that?
Yeah.
Yes.
So where they say R, we substitute. Where they say theta, we substitute. Therefore, we obtain structure like this. Any question?
Example.
Okay, what do they want us to do here? They want us to write this equation in the form of this one. So what are we left with is R and theta. Are we together? Are we still together? So now, R is given by the root of A squared plus B squared, where A is 1, where B is a root 3. Therefore, when you press your calculator, you will get 2. Any question from there?
Sipho.
Nda.
Ndabandika hold kumbe dovoleliwa.
Mene?
Ndabandika hold ndikumbe dovoleliwa zwone.
Apa.
Yeah.
Nobaka hold uchipinga chingapani?
Ikuita ichiimba yakahold chipinga chingi like for 2 minutes and then yaresume yadova yabva futi.
So Arbon, ndori vako todore ichi expression ti rote. Yo amba beire sa dojo ngaranka hold. Rote na. So, well, the ratio expression cha Z is equals to 1 plus I root 3. Reaching warenga indi. Rote. So, sinari cha koshota pandi R na theta. So, how do we get our R and theta? Our R is represented by this guy. Where A and B, we find them to this guy. Rote. So now, KZ yofuwa, ne dozo ifuanga A na B. So ne abana A, mpangera kizula ngurundi square root ya nepa lara substituta, rapia torera, zapia torera. Are we still together?
Yes.
So now, we want to find theta. We know that our theta is represented by A over B. B, your tan theta equals to tan arc B over A, where A and B, we find them here. So meaning that when they say B, we're going to substitute with B. When they say A, we're going to put A. Therefore, we press our calculator. We change our calculator to what? To Radi.
Okay.
Therefore, we get 1 over 3 pi. So now we have got our R, we've got our theta. So from the general, we substitute from this one. When they say r, we substitute r. When they say theta, we substitute theta. So it means we are going to obtain something like this. Are we together?
Yes.
So now, we know that if we've got a z is equals to 1 minus I root 3, our r is what here is the same, right? Isn't it? Our r is not the same. Hello? Our r is not the same. Our root of 1 plus open bracket minus root 3 close to the power 2.
You mean on a calculator?
But the one or two. This one r is given by that one for root of 1 squared plus open bracket minus root 3 close to the power 2. Are we together? Hello? Guys, come on. Rerotena.
Yeah, right. Zino already ndangwala simplifier ayo theta. Yasala I 5 ichipo time is no bisa 5 ngangomu apo za asala 1/3 ngangoma bracket.
Ngomba guy apa.
Ngeno magumo ka pendul.
Apa.
Ka theta.
Apa.
Here was a 5/3 pi. Nenda skanda enez. Ti na skanda
zonaro. Inezina. Atutu swika apa ne. Ino swika ngalipio. Neria in example there will be. Iyo toma yo perera apa. Guys, those are the two different examples. Here, our imaginary is positive. Here, our imaginary is negative.
Apo nani panda I ndi mine. Ndi 5 kana ndi essay.
I.
Not yapo, Sipho.
The essay.
Ngapo matungo ngapo ke expression cha matungo. Ka final answer. Ka error ko it
C is equals to 2 CIS into 1/3. Remember, we have to write it in the form of this. So are we still together?
Yeah.
Any question, guys? Example 1. It ends here. Example 1. This is our example 1. This one. And here, if you can check, okay, guys, why did we say theta is equals to tan into root of 3/1? Because I have stated everything is here on your notes. Theta is depend on the location of what? Of z. So our z location is here. And we know that theta here is equals to what? Tan. Are we together? Hello. So now, can you plot this? Can you plot this guy? Yes, it's 1 and root 3. It's on the first quadrant, right? This is our z. And do you understand now?
Yes.
Our z, it helps us to find the angle because the angle, it depends on the location of z using those guys over here. Are we together? Okay, as an example, hello? As an example, let's say here there was negative. You see, it's -1 plus I root 3. Are we together? Okay, so now to plot this one is -1 and root 3. It was going to be here. Can you see that? -1 and root 3. It was going to be here. Coordinate. So it means our theta was going to be equals to pi minus, we know that theta is tan arc. Any question? Any question? You can understand, right? Yes. Okay, so now go to the next example. Yeah, here it is. So this z is equals to 1 2 root 3. Are we together? So now let's plot this guy here. Let's plot this equation. We have 1 which is positive, is on the x-axis, and the negative what? Root 3, which is here. It means this guy is on this quadrant. Let me show you by the quadrant. It's here. Are we together? Here it means our theta is going to be equals to what? Our theta is going to be equals to what? Guys, are we together? Are we together? Hello? Ugolo no duraka hold. One. Hello?
I look hold.
One.
Okay.
So, Arbon, boss lady Nione.
Hey.
Okay, Jane. Rejani.
Yani.
Uko difilana kwamba kapara FM namze.
Sipho.
Okay, I'll continue. So now, as you can see that our equation, when we plot it, it is here on the fourth quadrant, which is 2 pi minus alpha, meaning that but you know that alpha is equals to tan arc b over a, right? So it means here you are going to substitute. Here it is, our theta is equals to 2 pi, which is this one, minus alpha is tan arc b over a, which will take it here, b over a. I will still together. Therefore, you press your calculator, which will be on the radi. Therefore, you kill the cat. Any question? Now, after finding r and theta, you substitute them back to the original, which says z is equals to r cis into theta. Any question, guys? Any question? Hello?
No question.
No question.
Yeah.
So if there's no question, this is the end.
Eh. Yango.
Real tiros liwa masinora veres.
Stefan record up.
Huh?
You got the record na.
They man stop o share screen. I be recording the rest of again though. Son say na yan kun. An kun zo stop again so say. K.